With that, we're on to today's session. I'm not sure how to correctly pronounce your name, so I'm just going to say Greg. You said so in your email correspondence that I could, so I will present you as Greg. And you are a senior BI developer and tech team lead in, is it called Kearney? That it's a global company, but in the Warsaw department or branch, you're the tech team lead. You're certified Power BI and AI, among other things, and you've presented at various user groups and online as well. Lately, or latest at the Budapest BI Forum, if I'm not mistaken. Did you present there or in November? Okay. So we haven't met in person, but hopefully we'll at some time. And I hope this session will go well with the attendees. And I'm very much looking forward to hearing about DAX window functions in practice. As always, I will go off camera. I will still be here. I will be monitoring the chat for any questions or comments. So just ping your interest in the chat, and let's hear it from Greg. Please take over.
Thanks, Jens. Thanks for the invitation. That's point one. And welcome, everyone. I'm delighted to be here and be able to present this topic for you. So today we will be speaking about the window functions in DAX, and I will show you the agenda in a moment. We will dive straight into it. First, I would also like to quickly introduce myself. So Greg is the correct English speaker's friendly pronunciation. The standard pronunciation of my name would be Grzegorz, but that might be a bit difficult to say for non-Slavic language speakers. So Greg works perfectly, and that's how I usually introduce myself as well. And currently my role is a senior BI developer in the Kearney Warsaw office. Kearney is an international consultancy, management consultancy, and I also act as the technical team lead for Power BI for the team. And my specialization is basically Power BI and all things around it, from designing data models and data pipelines and data warehouses that come before Power BI to the data models and the famous star schemas inside Power BI to the visual part, as well as my favorite part of the whole thing. So DAX challenges and mysteries that I help with my team, and that they also like to come up to me as well. So that's more or less about me. Let's get straight into the topic of the session, so window functions. What do we have in the agenda today then? First, I will be talking about, during the first part of the session, I will be talking about a bit of theory, so what window functions in DAX are, in the context of Power BI, of course. So why should you be interested in them? How can they help you? Then we will go over a number of use cases still in theory, where you will understand when to use which window function, since there are three. During the third point and the last point of the theoretical part, we will go into the syntax of window functions, since at the first glance, this syntax might seem a bit intimidating, but trust me, it's really intuitive once you get to know that and try to basically read it. And I will hope to guide you through that. And during the second part, so the live demos, we will get into Power BI and see some examples, some live examples that I have prepared for you for the most frequently used use cases for the window functions, actually from the consulting industry, as well as the use cases that are from other industries that you might find useful. But before we jump into the theoretical part, so before we depart, I would like to just tell you two things about window functions. So first, they are a relatively new addition to Power BI. They were added around a year ago and are constantly improved since then. And they basically hope to automate some operations that are relatively simple in tools like Excel or SQL. If you have used window functions in SQL, then there will be some similarities here, and it might be a bit easier for you to grasp the idea of the window functions in DAX. If not, then no worries. I assume that you haven't used window functions anywhere else, not even in Excel. So I will show the use cases and where can it be helpful from the very beginning. And the second point about window functions is that They simplify a lot of things. That's why they were invented and can optimize and simplify your DAX code. But generally, all of the things that are possible with the window functions, so all of their functionalities, were previously possible with a longer and more intricate DAX code. So, for example, you can still do all these things that I will be showing you using non-window functions, but your code will be longer and might be slower as well. Yet, I still highly recommend the use of window functions, since to me, once you learn them, they're also much, much more intuitive. All right, let's get into it. So first, window functions in a nutshell. What are they? How do they work? Generally, the window functions, I'm looking at the top left corner now. What do? They return a row or set of rows from a sorted table. So from this sentence, from this definition, we know that we need 3 elements to make the window functions work. First of all, we need first a table so that we can return our rows from this table. Then we need a sorting order that can be defined by 1 or more columns or measures that are not physically part of the table as well. And then we need to know which rows do we want to return. And for the rows to be returned to be a meaningful suggestion to DAX, we also need the sorting order, because we are not interested in returning random rows from the table. We want specifically the first row, the last row, or the one that's above the current row, like Excel style comparison. So the comparison of the change or the difference from the current cell to the one above it or below it, and so on. Once again, the window functions need 3 crucial elements to work. We need the table, and for that, we usually have to leverage the summarize and all family functions to get a table. If we are talking about measures in terms of the calculated columns, we don't usually need that to remove parts of the filter context. We need the sorting order. So for example, we want the best channel by sales. So the sales with the highest channel. So then we want to theoretically sort this table by the sales amount in a descending order, so that the channel with the highest sales is at the very top. And then we need the rows to return. So that would be the first row, so the best channel in this example, or the second best row, so the second one from the top, or maybe the last one, the worst item in terms of sales. That's it when it comes to the essence of window functions. Now let's get into some real use cases that you might face in your work to actually show you when can you use a window function and which one would that be. And we'll get to syntax later. So there are generally 3 window functions, and I will be introducing them one by one. The first one is index. And an example use case for such a function would be that we want to get the sales of the best country or the best subcategory or the best product. So in a nutshell, we want to calculate the value for all of the rows of the item that's the best or the worst. That would work as well. So in this specific example, we want to have in each of the rows in the next column that will be shown in a moment, we want to have the sales of the country that has the highest sales. So United States in this example. So ideally, we would like to have a result like here. In each of the rows, we show the sales of the best country. So if we try to translate it from a business requirements language, like we want to calculate the sales of the best country, technically we would say we want to show the sales value of the country, so the category that's the best, which would roughly translate to we want the sales value from a table that has 2 columns, that's country and sales, and we want the first row, basically the one from the top, sorted by the column sales in descending order. So we have 3 elements. We have a table to iterate, we have a sorting order that would be sales descending, and we have the row to return that would be the first one from the top. Similarly, we can return not just the best country, so the best item, the first row basically from the table. we can also get the sales of the worst country, so Thailand. In this example, that would translate technically to the last row from this table. Or we can just want to have the sales of the third best country or the fifth and so on, which translates to the third row from the table or the fifth. Of course, if we are talking about measures here, so having something dynamic, which I will also demo to you in Power BI in a moment, we also want to have this dynamically and like interactive to the user context, so to the filter context, basically. In that case, usually the all function again comes handy so that we can have the whole list of countries in this specific example. And another use case for the index function still, so the one that returns just the one row, would be returning the sales value of the country with the highest share of returns. So we actually now sort the table by one measure, that would be the share of returns, and here we can see that the Italy has the highest share of returns, but we want to return a different measure for that country. So we want to know what is the sales value of the country that is performing worst in terms of the quality of customer service, probably because we have a number of returns here, and we would like to know why, basically. And why would you like to have such an additional column with either the country of the best sales or with the sales of the country that has the most returns? Well, we can then compare the current row value versus the other one. So in this example, we can see in either an absolute or relative difference how much bigger is the current row or smaller compared to the row that we are choosing to compare to. So for the United States, it would mean that we are like around 10%, we are selling around 10% more than the country which is performing worst in case of the returns. All right. Now, another window function, which would be offset, that would be a function that allows you to return a row or a value again, but from a row that we designate in a relative order. So we do not say that we want the first row from the table or the last one. We want just the one that's below or above the current one. And in this specific term, it would be the closest to something like an Excel style comparison. So we compare the current cell versus the one above it and see how much that differs. So in this example, for a specific row that we have, for example, India here and 78 million, we want to see in this row for India, the filter context of India, we want to see the sales of the previous country. So in business language, business requirements language, we want to see the sales of the country that's better by one place compared to the current one. In technical terms, we want to return the value of a row that's previous. So that has a position of -1 compared to our currently iterated row when we are sorting by sales in a descending order. One moment, I see that there has been some question. Thanks, Jens, for answering that. So Serban asks here, returning a row or set of rows from a sorted table is the same as saying filtering a table and returning that. What's the difference? From my understanding, there is no difference, but altering the expressions are simplified and performance are improved. Yeah, basically, that's another window functions are another way of doing it. As usual in DAX and in a number of other programming languages, you have more than one functional approach to get to your final result and to your final calculation. So we could just as well filter the whole table and say that we want the row that's first. But in window functions, in the world of window functions, we say that we want the first row from a table that contains this and that sorted by something. So in principle, yeah, that's functionally more or less the same. Let's get back to offset. So generally, the use cases for offset are returning the values that are placed relatively to the current row that we are iterating. That's, for example, if we are on the row for India, we could like to return the value of the previous row. That's the previous use case. We may want to return the value of the row that's the next one, so Russia in this case. Or we might want to return the value of the row that's 3 places before the current row, so Canada, or the value of the country that's 10 places after the current one. Both will work perfectly. So offset generally gives you the ability to get the value of a row that's placed relatively to the current one. So the previous, the one that's after, the one that's 2 places after, your typical Excel level comparison from the current row to the one that's after it, or the one that's 3 places after. But now, since we are speaking about Excel level comparisons and comparing to the previous row, we might want to compare our current cell value to the sum of the rows that are above it, for example. That would be kind of a cumulative sum or cumulative average, whichever aggregation you prefer. So in this specific example, for the window function now, that's a bit tricky semantically to say. For a window function that's called window, so the name of this window function is just window. We want to calculate the sales of all the countries that are before or are the current row. So in theory, we want to see something like that. In more simple terms, you would like to probably say we want to see the cumulative sum of sales by country, sorting by sales in a descending order. So that the value for India is the sum of all rows above it, and plus the current one, because it's cumulative. And you can easily check that this actually works because, for example, for China, the value for China for the sales cumulative is the value of China plus the value of United States, and so it goes. So using the window function, we usually like to return a set of rows that are used to compute something like either a moving average or a cumulative sum. These are the 2 most frequent use cases. But now, speaking about the window function called window, you could say that, hey, the index function was basically returning a row that we identify by its absolute position. So either the first one, the second one, or the last one from a table. The index was actually using the absolute position of the row. The offset, on the other hand, was using the relative position. So the row that's before the current one or the one that's after it. But if we look carefully at what we did in the window, in this use case for the window function, we actually returned all rows that start from the first row in the table up to the current one. So we are using both absolute and relative coordinates. Is that intentional? Yes, it is, because that's basically how the window function window works, and I will get into that in a minute. But first, let's sum up what we know about the use cases for the index, offset, and window function. So the index function always will return a row, and just one row from a table sorted again using its absolute position. So the first one, the second one, the third row, or the last one, the penultimate one. Typical use cases include the value of the best item, so the sales of the best country, the worst country, and so on. But also the newest, oldest KPI value. I will explain that in a moment. It's a bit of a more interesting and complex scenario. The offset window function, on the other hand, uses the relative position of the current row to determine which row to return. So we can say we want the value of the row that's before the current one, or that's after, or that's 2 places after the current row. We still need to sort that table by something, but generally we return just one row as for the index function, but using the relative position. Now, the window function is the most intricate of those 3, and we can return a set of rows, so more than one, using either the relative or absolute positions of these rows. And typical use cases include something like the cumulative calculations, rolling averages, also Pareto charts, but that's a variation of the cumulative calculation, you could say. And interestingly enough, the window function window can also return just one row because it's a set of rows is also a row. And basically the window function functionality covers the use cases of index and offset as well, but it also has the most complex syntax. So I would recommend to go for the easiest window function that you can use in your current scenario. just for the sake of simplicity and transparency. Now let's talk about the syntax of window functions. And we will start from the syntax of the window function window, so the last one and the most intricate one. So for the use case that I mentioned, the cumulative sum of countries by sales, that's the DAX code that I used for that. And here in parentheses, you can see the window function itself. And it looks kind of tricky and maybe intimidating at the first glance. Honestly, that's what my impression was when I saw that in the first place. So it might be a bit difficult to read, but let's actually try to work our way through easier examples first and then get back to this. And I promise you that you will be able to read that in 5 minutes or so. But first, before getting to the syntax, we have to navigate our way through the navigation logic of the window functions. So you remember that the index window function returned the rows by their absolute position, the first one, the second, or so on. And that's how you could return in the top right corner the country with the highest sales. And you can see that the first argument is just a number. That's actually the index of the row that we want to return. So it will always be like the first row in the table. Now we have to remember that it's sorted by sales, which is actually the last argument. This has the index number 1. The second row is 2, 3, and so on. The 10th row will have a number 10. On the other hand, if we start counting from the end of the table, then the last row will be designated -1. The penultimate row will be -2 and -3 and so on. So that's the absolute navigation that we can use. But now you could ask, all right, but how do we navigate in the relative navigation logic? So how do we say we want the previous row? Actually, the index function won't help you. We need the offset function or the window function, which can tell you, which you can use to return a relative row. So now, if we are on the relative side of things, so we are in the world of current row, previous row, and the next row, then imagine we are on the India row for a moment. Our current row has an index 0. So the next row will be +1. The next one after that will be +2 and so on. But the previous one will have the previous ones will have negative numbering, so that's -1, -2, -3, and so on. So if we say that we want the previous row, we want the row with the index -1. But remember, in absolute manner, so for the index function, -1 would actually mean the last row, so Taiwan in this example. Now, here's where the table, where the window function definition comes into play again. Because when we are speaking about the navigation, well, that is always navigation that's relative to the sorting order that we apply. So here we are sorting in sales by descending order. And you can see that this is actually the last argument of the offset function here, same as it was for the window, for the index function that we discussed before. So if we would now change the sorting order to ascending, for example, then the Russia row, if we would like to get that, that would be in the index -1, because now we changed the sorting order, everything rotated and changed the order, and now the sales, the countries with the highest sales will be the lowest ones, because we sort in an ascending order. So the first rows will be the ones with the lowest sales. Same goes for the index function, of course. That is also sensitive to our sorting order. And the last component of the window functions here that we have in the syntax here is the table over which we are iterating. So in this example, it's the all selected function over a column. This column that's called in this intricate way is actually this country column that we have here, of course. So we need to specify the table as well. And now you can see that all 3 elements and that we need for the window function to work actually come together, because we have the table as the second argument, we have the sorting order as the last argument, and we have the rows to return in either the absolute or relative manner. So if we try to pull all that knowledge together, for the use case 1, where we wanted to select the sales of the best country, so the index function, we want the first row of the table that's That's countries sorted by sales in a descending order. Now we can try to read that actually. Power BI, please give me the row. That's basically what the index function says, which is the first one from a table that contains just the country name, ordered by sales in a descending order. So if you try to read the window function in this way, I think that it will actually help you understand it. It helped me a lot, and basically it gave me some better insight into how this works and understandability of all of this. So in easier terms, the above sentence means return the sales, the country which has the highest sales. So here we return just the name of the country because we want to calculate the sales of the best country. But now if we put that, our window function, in a calculate statement, then we can get the sales of the country with the highest sales actually. So our window function was here, and we put that as a filter argument of the calculate function, which basically says Power BI, please give me the sales. And this index function will basically translate to the country equals United States, because that's the one which has the highest value in this example. Similarly, we can go for the relative comparison. So we want the previous sales of the previous country just as below. That's the use case that we also discussed a moment ago. So Power BI, please give me the row again, which is the previous one, because it's -1. Previous one relative to the current one. If we would put just one with a plus here, that would be the next row. But we want the previous, as you can see below. Again, from a table that has just the country names, and that table should be ordered by the sales value in a descending order. So basically, we again want just the sales of the country, which is previous in terms of sales in a descending order to the current one. So Excel style, like we want the value of the cell that's above. And now the intimidating window function, which we saw below, and the cumulative example. Window function has basically one more argument, because since it returns a set of rows, not just one row, then we need to specify where that set of rows starts and when does it finish actually. And the first two arguments specify where our set of rows that we are interested in actually starts, and the second one specify where does it finish. And so 1 and 0, you already know what does mean. It means the first row or the current one or the next one, and so on. And we also have an additional set of small arguments here that say either absolute or relative. And you already know that as well, that the absolute positions are like the first row in the table, the second one or the last one. And while the relative positions are like the row that's the current one, the previous one to the current one, or the next one. So here we basically say, Power BI, please calculate the sales for a set of rows that start at the first row of the table, because we use the absolute coordinates ABS. You can see that here, and we say the first row, so the one where the table starts. So we start at the row which is the first one, and we take all the rows that are up until the current one. So 0 in relative terms means the current row basically. And again, from a table that contains country names sorted by descending order. All of this syntax basically translates to Power BI, please give me the cumulative sales of the current country in this specific context. That's what you could hear from your business user or your business analyst that acts as a medium between you and the client. So that could be the business requirement here. But technically, we want a set of rows, just defined as here. Nice. So that was the syntax of window functions. But now, since the window function window can also return one row, because one row is also a set of rows, what could such a syntax mean? Let's think about it for a moment. If you have your ideas, please put them in the chat. I will just wait a minute. Please do your guesses. What could this mean? All right, we've got 2 submissions. Both are correct. So this basically means please calculate the sales for the best country in terms of sales again. And this is directly the same functionality as the window function index on the right. So Basically, we take all the rows ordered from a table that contains countries ordered by sales in a descending order, starting from the first row by absolute manners, so the country with the best sales, and we also end at that row. So basically, we just take only one row which corresponds to the country with the highest sales, and this is precisely what the window function index does as well in this context. So this is precisely the same. So you could think like, again, the window function, window, has all the functionalities of the index and offset functions. Why would I use the other ones? Well, functionally, there is no real reason to advocate for the index and offset function, but they are much easier to understand. So I would recommend going for the window function, which is the easiest to implement in your current scenario. So that is also the easiest to understand for someone who might be taking over the Power BI report after you, if that person is not that experienced in window functions. Cool. Now we went through the window function theory. Let's jump into the Power BI for the live demos for the last 20 minutes. There is a question, two questions actually. Let me go through them. In the previous example with the window function, so I guess we are talking about that one. How is it said that position 0, the current country is India in that case and not the other country? Well, I guess that was just specific to the example, because when I showed you this full use case, we had a bit more space on the slide. So then we went to India, but here I just show 3 rows because we have a bit less space on the slide. That's it. 0 means just the current row that Power BI is iterating in your table or in your chart in another visual. So basically, yeah, the position 0, the current country is always the current country in the, you could say, in the filter context. So in the context of the China row, 0 would mean China. So this 5.8 billion value translates to the United States plus China value. Nice. And can you use some expression instead of type number 1? That's an interesting question. I haven't checked that actually, but I will check that. I guess that probably you can, because it's the the function, all the window functions expect an expression, so you could use either paste number like I did in here, but also you could probably use a measure reference here, which would be dynamic in that case, but I will validate just to make sure. All right, and let's get into Power BI, and maybe let's put all the other questions at the Q&A part, because I'm afraid we might not have enough time for the live demos in Power BI. So, but I really wanted to show you just not the theory, but also practice. So all the other questions starting from now, I'm happy to take after the main part of the presentation, I think. All right, so let's start from the beginning actually. So again, the index function and comparisons like the best or the worst country. So you could have a report in your, you could have a page in your report like this one, where you have now brands, not countries, and you have just a sales measure. By the way, this data set that I'm using, so I didn't introduce that, it's the Contoso data set, the standard one. So sales over time, over channels, over product categories and regions and so on. So in this specific visual, we have the sales over brand. And what do we want to get? Well, we obviously want the sales of the best brand. So we would probably want something like that. Let's see if that works. Yeah, the sales of the best brand is always returned. That's the Fabricam. Let's check out the syntax. That's actually our good old index function. So let's try to read it. We want to calculate the sales of the first row in a table with the brand names ordered by sales in a descending order. So the sales of the best brand in terms of the sales value, you could say. That's nice. We can also check by using some cross interaction, for example, by filtering this whole dataset by product categories, that our ranking is actually changing based on other filter context that comes from the report, which is great. We don't have it hard-coded, perfect, because it's in a measure and it's an all-selected function. But if that's not your desired outcome, then instead of the function all selected here. You can use the all as well, but then, well, you will have always the same set of brands. From my experience, the all selected function usually is what the users expect. So we want the ranking to be dynamic in the current context of categories in this example. Nice. You could also notice something strange. So the sales of best brand also appears for rows that don't have the sales value. Why is that? That is actually because we remove the current filter context from the column brand name. So even for the rows that do not have the sales value, we have the sales of best brand, which, and this behavior again might be intuitive for you or not. Let me just show you how to make it more robust, you could say. So I have a new measure that I called sales of best brand robust. And I just simply check if for the current filter context, so the current row in this table, basically, we have the value of sales. And only then, if we have the value of sales, we want to return the sales of best brand. For some business users, it might be counterintuitive for the rows to like duplicate and expand and show even if there is no sales in the current context. So whatever works for you and your users would be the right thing. I'm just showing you what I would suggest to make it more user-friendly. Great. And now, since we have the sales and sales of best brand, we could also use that to calculate some kind of a difference or delta of the current brand to the leader. In that case, the leader brand gets a 0 from this measure, while the next brand gets a value. So we just check how far is the current brand from the leader in this area, and you could also use this comparison in not in an absolute manner, but in a relative. So we could calculate a percentage change to see that, hey, the contour, so the second best brand is like 80% of the best brand, but Leadwear, for example, is just 1% of the best-selling brand, so the difference is really huge. Once you have these measures, you could also build something like the chart below. It could help your business users understand the data better. I'm using tables here for simplicity because the window functions can be quite tricky and complex, but this also, of course, should be basically visualized at some point. So here you can see visually that Contorzo, for example, is not that different from the best brand, but Leadwear is just a small fraction of the leader brand, so it's really, really small. And again, that of course reacts to your current filter context. But having that, you could also think, hey, this measure that's called sales of best brand always returns in the current filter context the sales of the best brand, actually. So maybe my business user would like to see that for a given category. Let's try to build that actually. And that's one we can get. Even though we don't have the sales of the best brand in this specific visual, and we don't have the brand column, we still get the sales of the best brand. How can that be useful to you? Well, for a specific product category, you have a set of brands in there. But you might be interested to not sum the whole sales value, but just say how much within a given category does the best brand make. So that's again like an analysis that can help you how clustered your values within a given category are. So is the leader brand like totally dominating your category, or is it just 1/3 in this example? Or maybe are the values more distributed? So it's a distribution kind of analysis that for TV and video, we see that the best brand is just roughly 1/4, so 25% of the leader brand. But for the cameras and camcorders, the best brand is over 60% of this category. So that actually dominates quite a lot. So you could say that the cameras and camcorders category is heavily impacted by the sales of just one brand, and distribution is probably not very equal though. The values are quite clustered. Nice. Okay, let's get to another example, to the newest value. So let me actually show you another table where we have the values as a history of changes. Let's filter down to a specific set of rows so that I can explain it to you really quickly. Perfect. And what do we have here? Imagine that for your company, you are creating a report that actually tracks the budget for, let's say, the software spending. So how much are you spending for the fees to get your Microsoft 365 E3 license up and running? And now you are thinking about the target and how much you are hoping to spend for the March 2010 for that. And now, before this time, so like a year before, you could be estimating that you will be spending 52,000 for the consulting, for the not the consulting fees, for the software fees on the 1st of March. But then an important meeting comes and someone says, no, our initial estimate was way too big. We will actually be spending just half of it. And then after that, another meeting comes and they say, no, we will be actually spending a bit more than we initially thought. So this is like a history of changes format that's pretty popular in some databases, and I've faced that too. But how do you actually work with that format in Power BI? You could say that, well, maybe I could just summarize these values. Not exactly, because if you summarize these values for a given date even, and KPI and project ID, you will be summing different estimates. Well, you might want to be interested in just the newest estimate. So how are we thinking that, what's the value that we were thinking of the latest, so the latest estimate, or the last estimate? You might also be interested to see how our latest estimate is different from the previous one. So are we expecting a cost cut, or do we need to budget more for our fees for the software spend? And how can window functions help you with that? Well, coincidentally, or totally not, what we are looking for here is actually a window function, and the index window function, because what we are interested in returning is the latest value for a given project ID and KPI and date, but sorted by modified date, which roughly, technically translates to, we want to get the first row from a table that contains this and that, sorted by modified date in a descending order. So the value for the row that's the newest row, the latest estimate. So index over this table, sorted by modified date in the descending order. Let's actually see how could that work. So we will be looking for newest value. And let's sort that up as well, so that you can see that some values appear. So we have, KPIs like IT cost reduction, consulting fees, that maybe there is the software charges somewhere. So the latest KPI value would be technically something like, we want the first row from a table that's sorted by modified date in a descending order. Here you have it. But we are using the modified dates and KPI values, that's the number itself. And we do not want to aggregate the rows. We don't want to summarize them. We don't want to sum them or take an average. We just want the latest row. And that's how this could be implemented as an example. Also, you might be interested to see what was the previous KPI value. So the estimate that was the latest before this one, that's the value. We just change that we do not want the first row from this table. We want the second one. Then you might be also interested in a change between these two. So like a delta between these two, I would say. So either subtract one from the other, or do a relative delta, so a division. So window functions could be helpful for a history change format as well. Now, if we are speaking about the offset function, when we have the delta versus the previous value, so the current cell versus the one above it, for a given subcategory, we want the sales of the subcategory that's above it. Let's see. That's the implementation. So for projectors and screens, we have the value of the previous subcategory. That works. How is that implemented? Well, it's actually our offset friend function. So let's try to read it. Calculate the sales for the previous row compared to the relative current one from a table that contains the subcategories ordered by sales in a descending order. So just I want the sales of the cell that's above the current one. And we can also plot it nicely. We can also maybe like do a comparison percentage, like how much are we changing from the previous subcategory, how much are we declining. And the two last use cases would be the use cases for the window function, which is called window. So that would be the sales cumulative. Let's see that one first, actually. So this actually gives us the cumulatives. Oh, sorry, I took the one that was by country. Now it works. So for the current row, we want the sum of the values that are this row or above. So a cumulative sales by the category, by the subcategory actually. So for projectors and screens, you can see that this value is actually equal to the sum of the sales for the projectors and camcorders. And so it goes. It's a cumulative chart. That's very nice. And you might want to plot it on your some kind of chart as well. Let's put it as a line maybe. And now you can see like a value distribution. So how much are we increasing? Where are the sales concentrated over our subcategories? That is very nice. And it already looks a bit like a distribution chart, like a Pareto one, but we can make it even better. Before that, let's quickly just check out the logic. So we want the sales of the countries which are in a table that of the subcategories which are in a table of subcategories. We take rows from the first one, absolute, so the one on the top, up to the current row, so zero relative, ordered by sales in a descending order. And we end up with something like this. So this is indeed a cumulative curve, but we might want to get to something like that, which is a proper Pareto chart. So instead of the absolute values, like we had here on the line chart, we might want to have percentages. So I call this measure sales cumulative percent by category, but how do you calculate it? Well, actually the cumulative sum is actually just a variation of what we did before, because the cumulative percent is just this value. So the cumulative value for the current row divided over the total. So what we have in the total row, for example, and a sample implementation would be something like this. So our sales cumulative, which we already calculated using the window function window, divided by, in the denominator, by the sales for all selected countries subcategories, sorry. And this is just what we can plot later. So we just take the cumulative share of the current sum for the current row compared to the total for all subcategories. And just a quick check if that's responsive to our filter context. Let's choose just a few categories, and we can see that the chart actually adjusts. So the cumulative total is also, the Pareto chart is also responsive to the filter context, whichever you would choose here, be it a country, be it a brand, or whatever else you'd be interested in, maybe just a client. All right, and with that, we actually conclude. I would like to thank you for this session, and in a moment, I'm happy to stay for the Q&A session just a bit longer to answer any questions that might have emerged.
Yeah, thank you very much, Greg. That was a really nice introduction into window functions. And as we talked about earlier, they are adding new functionality to those quite frequently, and it's top of mind at the Power BI team, I think. So it's something that you would want to get under your belt, and I think you had a great introduction to the functionality and the use cases for that. So there was a number of questions that we didn't, take during the session as you wanted to, do your presentations. One question was, can we do field parameters to change the dimension, in our case, country, and that, I guess that was for a specific example that you had?
Mm-hmm. It was for one of the cases here. Let's actually get into it and see. It might be either of the window functions, doesn't matter which one. Well, and the thing with the field parameters is that unfortunately that might be a bit complex, because the field parameters will allow us to change the category that we have in the visualization. So in the table, in this case, or in a chart. So we will be able to change like what we are slicing by. But up to now, as far as I'm aware, there's unfortunately no automated way to like read into the measure and say, I want to use this window function or this measure over the currently selected value of the field parameter. So you can try to do a huge switch statement, actually, which might work, but that might not be the best in terms of performance. Depending on what the DAX optimizer chooses, it might actually choose to materialize a set of 10 tables for all of the branches from the switch statement, and that might end in a terrible report performance. The ideal solution here would be to have like a function here that would be an argument of the all selected or another all function that would say like currently selected field parameter from the field parameter that's called like this. But unfortunately, so far, there's no way for that. So you can try the switch statement if it doesn't kill your performance, and you can hard code the finite number of the options you have in your field parameters. That might work, but still, that's not the ideal solution to me.
So I'm happy Serban brought the field parameters into the play, because that was our previous session. Yeah. So this is also top of mind with some of the attendees, perhaps.
Great.
So next, and I think final question is, instead of if not is blank, can't you wrap the function in keep filters and have the same result as in don't show
let
rows?
Me actually go to this example so that we are speaking about the same one. So that was from the start. This was the robust version. Yeah, instead of not is blank, sure, which you can also, by the way, write just like this. So if sales exists, just an interesting fact. But I did the more literal version of the syntax here. Can't you wrap the keep filters function and have the same result? Don't show rows. All right, so something like this probably. That's what Grzegorz meant here. Well, apparently you can't. We just saw it live. And why is that? That's because the keep filters function can only be used in the calculate statement, which we don't have here. And that's, you could say that we actually have the calculate statement, but no, this has to be used as a top level argument of the, as the top level filter argument of the keep filter statement. So you can write something like this, and then our country, that it will work. But here we are using this as a, could say, second level element inside the index function, which returns something else on the other hand. But of course, generally for this use case, there might be other syntaxes and ways to achieve this functionality, that the sales do not appear for the countries which do not have sales. For example, something like that. And there might be much, much more. I just decided to go for this syntax and this way because it's probably the easiest to understand and just translate into something that's readable for a human.
Yeah. So on a final note, is there or are there any rule of thumbs where when to use Windows functions versus traditional, calculate and filter and so on? Do you have any, recommendations on when to use what?
Yeah, precisely. Whenever you can, try to use the window functions, as they are meant to not only simplify your DAX code, so make it shorter, more concise, and easy to read, they are also more optimized in terms of performance. Traditionally, you would use the calculate, the filter. You could also use functions like the top n for example, the first row, so the index. You could also use the rank x for the relative row placement, so the row that's behind the current one, that's after the current one. I would generally, wherever possible, go for the window functions. They are faster and also meant to optimize the code in terms of performance. So whenever you can and it actually works in your use case, I would try to go for the window functions.
Okay. Well, that's good advice. Always look to window functions first. And with that, I think we're wrapping up today's session. And very much thank you to you, Gregor, for putting in your time and volunteering to present on such a great topic. And you did a great presentation. I think someone called it gold dust. So that's quite some an acclamation, right?
Yeah. Thanks
Thank you.
for the time of everyone here, and thanks, Jens, for the invitation.
Thank you, and have a great day, everyone.
Bye.
Bye-bye.